Hi everyone, welcome to my channel. Today's problem is an interesting one. Imagine you are holding a chain with a mass m and length L. Below your hand there is a weighing scale. What will the scale measure when you drop the chain and it falls a length x? Take a moment to think about it and feel free to pause the video and work on the solution. Alright, let's dive into solution. Weighing scales measure the normal force when force applied to them. To figure out what force on the scale, we need to consider all the forces acting on it. First, let's take an analogy. When you stand on the weighing scale and jump, the scale measures the increased weight at the jump moment because of the additional force you exert. Similarly, when chain falls, there is an extra force beyond just its weight. This force comes from the chain's momentum. Now we have identified there are two forces acting on the scale, the weight of the chain and the impulse per unit time applied by the falling chain. Let's start with the weight. The weight of the chain segment that has fallen is straightforward to calculate. First we consider the linear mass density of the chain, that is mass per unit length, that is m is equal to m by L x. Next we use Newton's second law, that is F is equal to ma, where a is equal to acceleration due to gravity, that is g. So the first force is m by L into x into g. That is the first force, that is the weight of the chain. Now let's consider other force. As this small segment of the chain comes to rest upon hitting the scale, it transforms its momentum to the scale, exerting an additional force. First, you must know what is impulse is. Impulse is when a force is applied in a short period of time. It is defined as J is equal to F into delta T. But we need impulse per unit time to calculate that force. Now, we know that impulse per unit time is force. We can write force in the another form as delta P by delta T, where P is the momentum. Momentum P is equal to m into V. So we can define dP by dt, where P we can substitute as mv, where we will get dm by dt. In place of dm, that is linear density of the chain, that is dm is equal to ml by dt. When you substitute that, we will get m by L dx by dt into v. As we know, dx by dt is velocity, so when you substitute v, we will get m by L v square. By using motion equation, where v square minus u square is equal to 2as, where a acceleration is g and due to gravity, and s is equal to x, and initial velocity is 0. By solving that, we will get v square is equal to 2gx. By substituting v square in the ml by v square, we will get the final second force, that is 2m by L into gx. So now we got both the forces. So when the chain has fallen the length, the weighing scale measures the force total 3 mgx by L. Thank you for watching. I hope you find this explanation helpful. If you did, please like and subscribe for more interesting physics problems. See you next time.